Let's look at some things about types of data in Java. One thing to note is that Java is a strongly typed language. This means that when we declare a variable, we have to state what its type is, and that type does not change for the variable. I will only ever hold integers, S in this case will only ever hold strings, and D will only ever hold doubles. The data that's stored in those, as we'll see with some of our examples here, can be changed to be treated or stored as different types. When you take the actual data and store it or treat it as a different type, this is referred to as casting or typecasting. So the first type that we'll look at is called implicit casting. So some types of data I can simply take and store as a different type or use as a different type, and Java has no problem with this. For example, if I say D equals I, what that's saying is I's value should be stored as a double now. This seems reasonable because I is an integer. Any integer can be represented as a real number, as a double, right? So I will become 5.0 here, which is exactly equivalent to the integer 5. Similarly, we could take I's value and we could do math with it along with real valued things, doubles, and we can use I's value in math with doubles. It will get converted to 5.0, then added to 3.2, and then stored in D as the final result. So again, it's implicitly cast. We don't say, make I a double. The statement that we make is what to do with I mathematically, and Java will know that for I to be added to 3.2, or for I to be stored in D, it must take that 5 that was in there, turn it to 5.0, and then either do math with it or store it. The other sort of thing that we might want to do is to treat things as strings. This is a little more complicated because we can't simply say to store D, for example, the double, inside of S, the string. We can change D to be a string in a few different ways. So one of the most common ways that we often will do this is we'll probably have some text that we want to label it or to combine it with in the first place. And so we can simply tell it to add on to that string, and it will convert D to a string and then combine it with the string that exists there. So this again does it implicitly. I don't say D needs to become a string. I say take D and combine it with a string. Therefore, Java knows to turn D into a string and then to combine it with the starting string, the string literal, which really just means any string that's written in quotes with its exact literal value. So we can combine D's value with a string literal and store it as a string. And we'll see there are ways, if we didn't have additional things to combine D with, we can then explicitly change it. So there are a few cases where we absolutely need to explicitly state the type of data that we're wanting to treat our data as, the type that we want to treat our data as. So while we can store an integer as a double, one thing we cannot do is store a double as an integer without stating that that is for sure what we want to do. And again, I hope this makes sense because if D was 4.3 or 8.2 or anything with a decimal value to it, some data might be lost if we stored it as an integer. It will truncate, meaning cut off the decimal portion of the value. So 8.2 would become 8, 4.3 would become 4, 9.9 would become just 9. So it simply cuts off the decimal value. So Java won't allow us to do that. It won't allow us to lose that data accidentally. It will require us to explicitly state that we know D is going to be converted to an integer, and yes, we want that to happen. So this will store D's value as an integer, truncating, meaning removing the decimal portion. So that's one case where we would need to explicitly state that we want D to be converted because of that possible loss of data. There are other times where we want to change something into another type of data, and we can convert it using methods that exist for it. So for example, if S held the value of 3.3 as a string, then we might want to store that 3.3 as a double. We are not allowed to simply say D equals S. And again, this might make sense to you because there could have been some text that was combined with it. There could have been any type of other characters or information in there. So we do have to tell Java, yes, we want this converted to a string. One of the ways that we can do that is to use a parsing method for it, double.parseDouble, which really just means read the string, make sure that it's possible to use as a double, and if so, turn it into a double. So this is another way of explicitly changing S's value into its double representation. If it was not actually something that could be parsed as a double, this would throw an error, but at the very least, the programmer has indicated to Java, yes, I know there might be some data loss here, but I definitely want this changed into a double. And so you might do some error checking or things like that first, but we know now that the programmer did have the intention of changing this broader possible data type of a string that can hold text and can hold lots of different information. They want it narrowed down to a double. So any of the times that no information would possibly be lost, like turning an integer into a double, we can always just attach a 0.0 to it and its equivalent, then we are allowed to do that implicitly without stating that that's absolutely what we want done. Similarly, when we combine most things with strings, we are allowed to do that without explicitly stating, because Java knows that it can be converted into a string without losing information, and then can be combined with whatever other string was given there. When we might lose data, such as dropping off the decimal place from a double, we have to explicitly state that we want it cast to a double. And similarly, for things like strings, there are methods that allow us to change the type from the string to, say, a double or an integer.